Introduction to Algebra, and we'll be starting our discussion of algebra with algebraic expressions. So let's start at the very beginning. First of all, just what is algebra? Well, as it turns out, the word actually has a sophisticated definition in mathematics overall, but that doesn't concern us. For our purposes, algebra is the part of math that involves variables. So as soon as variables show up in math problems, that's algebra. Let's define some terms. A variable is a letter that represents either a specific number or all numbers. And this is a subtle distinction here. In algebraic expressions, the variable represents either all numbers or all numbers with very few exceptions, and the point in algebraic expressions is to find or use patterns true for all numbers. In algebraic equations, by contrast, the variables represent one or two initially unknown values, and the point is to solve for those specific values. So with equations, we're trying to solve. With expressions, we're just trying to find patterns that are true for all numbers, with the variables representing all numbers. So this is a subtle distinction, and we'll talk about this more. Some more terms. A constant is a number or a symbol such as pi that doesn't change in value. So just constant is just a fancy word we use for ordinary numbers. A term is a product of constants and variables, including powers of variables. So for example, all of these are terms. It could be just a single number by itself, a single variable by itself, or numbers times variables, and it includes powers of variables. The coefficient is the constant factor of a term. So for example, 6y squared, the variable y squared is being multiplied by the number 6. So 6 is the coefficient. Now if we look at x, just x by itself, you might think, well, gee, that has no coefficient. And this is subtle. When no coefficient is written, the coefficient is 1. Because, of course, x equals 1 times x. We wouldn't write the 1. That would be kind of redundant. But the point is, x has a coefficient of 1. And in fact, that last one, x to the 5th, y to the 6th, z to the 7th, that last term also has a coefficient of 1. Now, these three terms, constant, term, and coefficient, are terms that could show up on the test. The test question might actually mention one of these in asking the question. So these are very important to know. All the other terms that will come in this video are terms that we'll need in our discussion of algebra, but will not be things you'll need to know for the test. An expression is a collection of one or more terms joined by addition or subtraction. So all of these are examples of algebraic expressions. Notice expressions don't have equal signs. So once we get into the business of taking an expression and setting it equal to a number and solving, well, then we're talking about algebraic equations. We'll get there, but that's not what these first few videos are about. Here we're talking about individual expressions. Now we may say that one expression is always equal to another expression, but the point is each expression by itself is a thing without an equal sign. That's very important to realize. A monomial is an expression with exactly one term. All of these are monomials. They are single terms. Could be just a number, could be just a variable, or a product of numbers and variables. A binomial is an expression with exactly two terms. Here are a bunch of binomials, some of them simple, some of them not so simple. A trinomial is an expression with exactly three terms. And those are some examples of trinomials. Now, we don't have to worry about what if there are 4 terms, what if there are 5 terms. We don't need to worry about the words for those. A polynomial is an expression with any number of terms involving only one variable. So, for example, this one here is a polynomial because the only variable is x. This one involves more than one variable. So technically, that's not a polynomial. A linear term is a term with a single power of a variable. So there's no exponent written. So just when you have a variable by itself or a number times a variable, that's a linear term. A quadratic is a term with a squared variable, x squared or y squared. A cubic term is a term with a cube of a single variable, y cubed or x cubed. And we will not need terms for higher degrees. Now we'll make a distinction, and this is a little tricky. The words linear and quadratic can describe individual terms, but they can also describe the entire expression involving a single variable. In a linear expression, the highest power of the variable is 1. So 17x is a linear monomial, 3x minus 5 is a linear binomial. So one of them, it's a one-term thing, the other is a two-term thing. And notice we don't have many options here. A linear binomial must have one linear term and one constant term. As long as we're dealing with only one variable, those are the only two options for the two terms. It gets a little more interesting when we talk about quadratics. In a quadratic expression, the highest power of the variable is 2. So 14x squared, that is a quadratic monomial, a single term where the highest power is 2. X squared minus 4 is a quadratic binomial with a quadratic term, x squared, and a constant term, negative 4. 2x squared plus 8x is a quadratic binomial with a quadratic term, 2x squared, and a linear term, 8x. X squared minus 10x plus 25 is a quadratic trinomial with a quadratic term, the x squared, a linear term, negative 10x, and a constant term. And so, for example, we could ask, what is the coefficient of the linear term? The coefficient of the linear term here is negative 10. Many of the upcoming videos concern quadratic trinomials. That's a very, very big topic in algebraic expressions. We have a bunch of videos on that topic. In the study of algebraic expressions, we are looking for rules or patterns true for all numbers. In the study of algebraic equations, our goal is to solve. So again, these first few videos are just about algebraic expressions, then we'll get to algebraic equations. We discussed several terms: variable, constant, term, coefficient, expression, monomial, binomial, trinomial, polynomial, linear, quadratic, and cubic. And these are terms important to know because we will be using these terms in our discussion of algebra. Our first topic in algebraic expressions is simplifying expressions. So suppose we were asked simplify 3x plus 5x. Now, of course, this is a very easy question. The test is not going to ask something this basic. But suppose we have to simplify 3x plus 5x. Of course, 3x plus 5x equals 8x. Now, let's think about this for a minute. We've said one expression, 3x plus 5x, is equal to another expression, 8x. So what we're saying here is we have a rule that's true for all numbers. Every single number on the number line would obey this particular rule. And of course, we can add 3x plus 5x using the distributive law because they are like terms. Now, what do we mean by like terms? Like terms are any two terms with the same variable part. If they differ at all, they differ only in coefficients. The number one algebraic simplification rule, we can combine like terms by addition or subtraction. And in essence, we're just adding or subtracting the coefficients. So for example, 15y minus 8y, both of those are like terms. The variable part is just y, so we can subtract. 15 minus 8 is 7, so that's 7y. 3y squared plus 3y squared, those are like terms. In fact, they're identical. So when we add, we just get 3 plus 3, which is 6y squared. And that final one, notice that thing is awfully complicated, but the two terms are actually like terms because the variable part, x to the 5th, y to the 4th, z to the 7th, those are identical between the two terms. So we have 2 of the thing plus 1 of the thing, and of course whenever you have 2 of anything plus 1 of the same thing, you get 3 of that thing. So that's how we simplify that. Notice that we can add or subtract only like terms, not terms with different variables or powers. So if we look at this expression, we can't just add everything together because what we have here are different powers of y. So we have to group the terms by the like term, by the powers of y. So the cubic, y cubed, that's going to be by itself. We group the two quadratic terms and the two linear terms. And then within those parentheses, within those groupings, we can simplify. So we get down to this simplified expression. Also, notice that multiplication is commutative. In other words, a times b equals b times a. You can switch the order around and it doesn't change the multiplication. So the order of factors in multiplication doesn't matter. Therefore, like terms may appear different if the multiplied variables are in a different order. So they're not really different, it's just a difference in appearance. So for example, 5xy plus 7yx, those are still like terms because xy and yx are the same thing. The order doesn't matter. So those are like terms and we can add them. And even this one, the second one, this is more complicated, but notice that all we have are the same factors, the same variables, just multiplied in a different order. And so we have 6 of something minus 4 of the same thing, which would be 2 of that thing. So now, pause the video and simplify these, and then we'll talk about these. So in the first one, we have to group the like terms, and it simplifies to this. In the second one, we have to group the like terms, and it simplifies to this. In the third one, it turns out there's no simplification possible because no two terms are like terms. So that's as simple as it gets right there. Another simplification topic is how to combine algebraic expressions involving parentheses. Parentheses. This is a big mathematical topic, parentheses. When an addition sign appears in front of the parentheses, we can simply remove the parentheses. That's very easy. So we have this, then we can just write the exact expression again as if there were no parentheses at all, just basically erase the parentheses, and then we can do our simplifying from there. And it turns out this simplifies just to the single cubic monomial 2x cubed. When a subtraction sign appears in front of the parentheses, things are a little trickier. In removing the parentheses, we have to change every sign inside the parentheses to its opposite. Addition inside the parentheses becomes subtraction outside, and vice versa. So here, we're subtracting those parentheses. So the first parentheses we can just remove without any problem. But the second parentheses, when we remove those, the addition of 3x squared inside the parentheses becomes subtraction outside. And the subtraction of 3x becomes addition outside. Those two change to its opposite. And once we have that, then we can simplify, and it simplifies to this. Pause the video here and simplify these expressions. And these are the answers. So in summary, we can simplify algebraic expressions by adding, subtracting like terms. That's a really big idea. When adding an expression in parentheses, we can simply remove the parentheses. When subtracting an expression in parentheses, we have to change each term to its opposite sign when we remove the parentheses. In the previous lesson, we talked about adding or subtracting algebraic expressions. In this lesson, we will begin the discussion of multiplying expressions, looking at the two relatively simple cases, monomial times monomial and monomial times binomial. Before we begin, let's be clear on a few arithmetic principles. It's very important to realize when we get to algebra, all the algebra is obeying basic arithmetic principles, and so we have to be clear on our arithmetic. Remember that multiplication is commutative and associative. This means that we can put factors in any order or groupings and not change the product. So for example, A times B times C times D, that's exactly the same as B times A times D times C. We can change the order. We can group them. We can do A times D and then B times C and then multiply those two together. We could do C by itself times BDA. All of those are exactly the same, and there are many, many or more groupings and orderings possible. The point is, it doesn't matter what order they're in. It doesn't matter how we group them. As long as everything's getting multiplied together, we will have the same product. That's a really big idea about multiplication. Also, we need to be clear on the distributive law. Multiplication distributes over addition and subtraction. So if we multiply A times the quantity B plus C, we multiply each individual term. If we multiply A times the quantity B minus C, we multiply each individual term. Multiplication distributes over addition and subtraction. Multiplication does not distribute over multiplication. So 3 times xy does not equal 3 times x times 3 times y. We do not get two different factors of the 3, one multiplying each factor. We don't distribute over factors, we only distribute over separate terms, and xy is a single term. So in fact, if we multiply 3 times xy, we just get 3xy. Very important to be clear on this. This is a subtle mistake. All right, so now we can start talking about multiply. If we multiply a number, a constant, times a monomial with a variable, the constant multiplies the coefficient. So for example, 7 times 5x squared, that's just going to be 35x squared. We're just going to multiply that constant times the coefficient. 2 times r to the 4th, s squared t cubed. Well, the coefficient is 1, so it would just be 2 times 1. It would just be 2 times that same combination of variables. What if we divide a monomial by a number? Remember that dividing by a number is the same as multiplying by its reciprocal. That's something we discussed in the fraction videos. So we have 15 x to the 6 y to the 12th divided by 3. What happens is just that coefficient is going to get divided. Now we can think of this as being multiplied by 1/3 if we like. Just that coefficient is going to be divided. The variables are going to be unchanged, and we're going to get 5 x to the 6 y to the 12th. Now we will discuss multiplying two monomials, each of which contains variables. Remember that x times x is x squared. Something squared means something times itself. And x squared times x is x cubed. For higher powers of x, recall the rule for multiplying powers. So when we multiply two powers, x to the a times x to the b, we simply add the powers. That's x to the a plus b. So why this is true and what's going on with all these laws of exponents, there are many other laws of exponents, and we'll cover those in depth when we get to the powers and roots module. This is the only law of exponents that I'll mention here, and this is probably familiar. When we multiply powers, we add the exponents. For example, suppose we multiply 3x times 4x squared. Well, first of all, we're going to multiply the coefficients. 3 times 4 is 12, and x times x squared is x cubed. So this product is going to be 12x cubed. Now, if we have this one, first of all, we'll multiply the coefficients. 7 times 6 is 42. The x squared times x will be x cubed. Now the y squared times y cubed, we have 2 factors of y times 3 factors of y. That will give us 5 factors of y. We'll add those coefficients, we'll add the exponents of y, the 2 and the 3, and we'll get y to the 5th. And so the total product will be 42 x cubed y to the 5th. And the powers of the different variables stay separate. It's very important not to start mixing up the exponents of x with the exponents of y. You can get very confused if you don't keep the variables separate. Here's some practice problem. Pause the video and then we'll talk about these. So these are the correct products here. Now we'll talk about the case of a monomial times a binomial. For this we use the distributive law. So a times b plus c equals a times b plus a times c. This is proper distribution. So for example, if we want to multiply 7x squared, that monomial, times the binomial in parentheses, we have to multiply that binomial times each term and then do the correct monomial times monomial multiplication for each term. And here we would get 7x to the 5th plus 14x to the 4th. Clearly, we could extend this pattern for monomial times a trinomial or any higher polynomial. For example, here's a monomial times a trinomial. We'll multiply that 5x times each individual term, and we'll wind up with this product. If there were more terms in the parentheses, we would just distribute the monomial multiplication to each term. Here are some practice problems. Pause the video here, and then we'll talk about these. And here are the answers. In summary, in this video, we talked about the basics of algebraic multiplication, including multiplying two monomials and multiplying a monomial times a binomial or trinomial. In the next video, we will discuss the case of multiplying two binomials. Now we can talk about the FOIL method. In the previous lessons, we multiplied expressions in situations in which no more than one of the factors had addition or subtraction. When we multiply two expressions, each of which involves addition or subtraction, how to distribute becomes a little bit trickier. So think about this. Here we have two binomials, that is to say, two factors, each of which involves the addition of two terms. And so how do we distribute? Well, technically, we would have to distribute one factor. And so let's say that second factor, r plus x, that whole thing as a factor, we'd have to distribute it across the first addition. And so we get p times that factor plus q times that factor. And then once we get to that point, we'd have to distribute in each one of those terms. Distribute the p in the first term, distribute the q in the second term. And so that is technically what we would have to do to distribute. You can think of the process using the distributive law in that way, but there's a very convenient shortcut summarized by the mnemonic FOIL, the word FOIL. So what does FOIL stand for? Well, FOIL stands for first. So by first we mean the product of the first two terms inside the parentheses, p and r. Each one of those is first in its own parenthesis, and so the product of the first terms, that's one of the terms. Then we look at the outer pair, that is to say the very first in the first parenthesis and the very last in the last parenthesis. Those are the outer ones. Then those of course are the inner ones. The last in the first parenthesis and the first in the last parenthesis, q and r. And then finally, we look at the two last terms, the last in the first parenthesis and the last in the last. So those are the four pairs we're going to look at, summarized by first, outer, inner, last. The product of the binomials is the sum of those four individual products. So in other words, if we add first plus outer plus inner plus last, that is the product of the two binomials. Here's an example, the use of FOIL. So let's go through this very slowly. Here we have two binomials. The first product we're going to take, the f, that's the first term. So that is the 2x from the first parenthesis and the x from the second parenthesis. So 2x times x is 2x squared. Now we're going to look at the outer products. That would be the 2x at the beginning and the 2y at the end. That product is 4xy. Now we'll look at the inner products. That would be the y times the x right in the middle. Y times the x, that's xy. And then we'll look at the last. So that would be y times 2y, which would give 2y squared. Now that we have those four individual products, we add them. And of course, when we add them, we have like terms. You often get like terms in foiling, and so we simplify by combining the like terms, and that is the product. Here's another example of foiling. So again, two binomials, this time involving subtraction. So the first would be 2x times 3x, that would be 6x squared. The outer would be 2x times negative 1. We have to remember to include the negative, so that would be negative 2x. Then negative 5 times 3x, that would be the inner, that would give us negative 15x. And then the final term, negative 5 times negative 1, gives us positive 5. And again, combine the like terms. Here's another one with some higher powers. This is good practice for that power rule. When we multiply here, we get x to the fourth times x to the fifth. And as we talked about in the previous video, what happens when we multiply powers is we add the exponents. So 4 plus 5 is 9, so x to the fourth times x to the fifth is x to the ninth. And if that's something that's unfamiliar to you, I would suggest go back and watch the previous video, or go ahead and watch the powers and roots videos where this is explained in much more detail. The outer terms, x to the fourth times x squared, 4 plus 2 is 6, so that would be x to the sixth. The inner terms, x times x to the fifth, 1 plus 5 is 6, so that's also x to the sixth. And then the last terms, x times x squared would be x cubed. And again, finally, add the like terms. Here's some practice problems. Pause the video here and work these out on your own. So the first one we FOIL out, we get those terms and they simplify. The second one, we get these terms and they simplify. The third one, we get these terms. In this context, we can also discuss a very common algebraic mistake pattern. And just as it's important to know the correct things to do, it's also incredibly important to understand the common mistake patterns, because these common mistake patterns are very often tempting incorrect answer choices that many people pick because they make these mistakes. So here's the common mistake. If we have a binomial squared, so many people are going to be tempted to say a plus b quantity squared equals a squared plus b squared. They're going to be tempted to distribute that exponent, and that is 100% incorrect. It is absolutely illegal to distribute an exponent across addition or subtraction. We can distribute multiplication across division or subtraction. That's the distributive law. We cannot distribute an exponent. Instead, squaring anything means multiplying it by itself. Thus, squaring a binomial means multiplying the binomial by itself, and we would FOIL in that process. So if we do this properly, a plus b squared, well, anything squared is that thing times itself. So it would be a plus b times a plus b. That's what it means to square something. Well, now we have a product of binomials, so now we would FOIL. We get those terms, we'd combine, and we'd get that. So this is very different from just a squared plus b squared. We get that, what's called a cross term to ab, the term where the two variables are multiplied together. And in fact, this is a very important pattern. This rule, a plus b squared equals a squared plus 2ab plus b squared, is called the sum of a square. And it's very good to be familiar with this pattern. It's very good to FOIL this out and practice this until you really know this pattern inside out. A similar rule, the square of a difference, can also be found by FOILing. This is a minus b squared equals a squared minus 2ab plus b squared. These two formulas, the square of a sum and the square of a difference, are good to remember because they are two of the most important patterns in all of algebra. And again, I'll make the distinction here. Don't just blindly memorize them. Practice the FOILing. FOIL them out. And that way, you'll really own these formulas because you'll understand where they come from. In summary, we discussed the FOIL method for multiplying two binomials, and we discussed two important formulas, the square of a sum and the square of a difference.